It's usually stuff that can be verbalized unless they got you trying to write equations of sinusoid functions, and then that's something that we would have to look at. So, hold on one second. All right, go ahead. What do you got? Okay. Is it a right triangle or? Okay. If you want to just give me the 3 pieces of information you have, I can draw the triangle. Do you have like angle A, side A, stuff like that? Why don't you give it to me? Yeah, give it to me that way. What do you have? What do you have? What pieces of information are they giving you? Or are they giving you a picture of a triangle? I mean, okay. Okay, let me go ahead and draw it like that again. A is at the bottom like that. B, C. Okay, what do we got? Okay, that's actually side C. Okay, okay. $11, okay. Okay, so they want you to solve for that. So what trig function? First of all, do we have to complete the triangle? Do we have to finish dimensioning it? Not really. We don't need to. We could use Pythagorean's theorem to do it. But there's a trig function that already relates 8 to 11. In other words, side little c to side little a. What is it? Which trig function relates those two sides? Sine of theta equals opposite over hypotenuse. Okay? So now all you got to do is take, in other words, to find theta, you take the inverse trig function, the inverse sine of that number, 8/11. That's always the way it works. In other words, we're always taking trig functions of angles to get ratios, and to get angles, we're always taking inverse trig functions of the ratio. Now, do you have your calculator? This is the one you're going to need your calculator on this, because this is going to be it's not going to be an integer answer. You need to get it, yeah. Doesn't do you any good for me to do this. What do you have, a TI-84? Okay. Now to do the inverse trig function. Okay, let's back up a second. Make sure that that is in parentheses. In other words, don't do the inverse trig of 8 all divided by 11. Make sure you're doing the inverse trig function of 8/11. Second, are you in radians or degrees? Probably you want to get in degrees. If they want their answer in degrees, then you need to get into degrees. You know how to do that on there? Okay. Okay, 46.65. Did they give you any rules as to how to round it off? Is it always to 2 decimal places? She'll take that? Okay. Because if she wants you to round it off to 2 decimal places, we need to know what the next decimal place is. Okay. To what? How many decimal places? Then what's the next digit after the 5? So what's the answer? Yeah, you might lose a point if you did that. Okay, what else? What else we got? Are all of these going to be triangle problems like that? Okay, let's do a couple more. I don't think we need to do all of them because they're pretty easy once you get the hang of them. Okay, call that little c. So little c is always the side opposite angle c. So that's 7, okay. What else? Okay. Well, that becomes the same problem as we just did. So I would have preferred it if little b would have been 19. Okay, so this is exactly the same. What am I going to write? Which trig? In other words, that's the sine of theta equals 7 over 19. So theta is the inverse sine of 7/19. Just same problem, different numbers. Do we have a similar problem where it's not exactly the same? In other words, where they give you 2 different sides, then the opposite and the hypotenuse. Because if they gave you, let me make one up. I'll give you that one. Okay? What would you do now? Well, hold on. You have to figure out which trig function relates 7 and 12. Just like on the last problem, we had to figure out, no, cosine is adjacent over hypotenuse. We don't have the hypotenuse here. Sine is opposite over hypotenuse. We don't have the hypotenuse. But there is one trig function that doesn't use the hypotenuse. Okay, so tangent of theta equals what? Which makes theta equal what? Give me all 3 digits. Or are you rounding it? When you, okay. I'll leave that up to you because I'm not checking with a calculator your work. So, okay. So as long as they give you 2 sides, you don't actually have to figure out the 3rd side. You can always find a trig function that relates those 2 sides. Always. It'll be either sine, cosine, or tangent. And if they give you one of the small sides and the hypotenuse, it'll be either sine or cosine. So, what else you got that's a little different than those? Because I think you know how to do those now. Okay? Okay, give me the 3 pieces of information. The way they give it to you. Correct. Right. So, That's 28. That's 101, which makes this C, this B, this C, and that A, and little b is 10. Okay? Now, clearly you are familiar with the law of sines, and that's what we have to use to solve this. Okay? They've given us 3 pieces of information, 2 angles and 1 side. So we have to figure out the third angle and the other 2 sides. The third angle is the easiest part. Let's do that first. How do you get the angle A? Just tell me what it is. No, angle A, what's the sum total of the 3 angles of a triangle? Always equal to. Go ahead and, So what is that, 51? Okay. Now you have to use the law of sines. In other words, all of our nice trig functions, like opposite over hypotenuse, those only work on right triangles. When you're working on a triangle that's not a right triangle, you have to use the law of sines. And the law of sines basically says that the sine of an angle relative to its opposite side, that ratio is always the same in a given triangle. In other words, in this triangle, that is going to be true. So, how can I solve? Let's try to solve for little c first. So give me an equation that's going to let me solve for little c. No, that's also right triangle only. Pythagorean theorem only applies to a right triangle. No, it's using this stuff down here. Which one of those ratios do we know? Is it this one? No, we don't know the sine of A. Oh, we don't know the opposite side. But when I say which one do we know the numerator and the denominator of? Right. So I can say the sine of 28 degrees divided by 10 equals the sine of 101 degrees, angle C, divided by little c. And now we can solve for little c. That's the only unknown in that equation. Sine of 28 degrees is a number, sine of 101 degrees is a number. So, little c equals 10 sine 101 divided by sine 28. So you can come up with that number. So all I did was cross multiply here and then divide by the coefficient in front of c. .91 is little c. Okay? And now we have to use the same process to find little a. In other words, I don't have anything that tells me what the circumference of this thing is. So the only way I can solve for a, little a, is by using this law of sines again. Now, just to make it slightly easier, I can flip these. In other words, this is also true. Okay? And the reason that's going to make it slightly easier is because then I don't have to cross multiply. You'll see. Hold on. So I'm going to use that same ratio flipped. In other words, I can use that all the way through the problem. And it's going to equal to little a over the sine of 51 degrees. You with me? Now you see why that's easier to solve? I only have to do one multiplication. I got to multiply both sides by the sine of 51 degrees. I don't have to cross multiply and then divide. So a is immediately equal to that in one step. Whereas when I did it over here where the variable was in the denominator, I had to cross multiply and then do a second step. So whenever you have a choice of which way to write this thing, try to put the variable you're solving for in the numerator. Now, when I say you can flip these, you have to be consistent. In other words, I can't say that's equal to little b over sine b. You with me? You can have the sine in the numerator and the opposite side in the denominator, but it has to be consistent. So what is that answer? 10 times sine of 51 degrees divided by sine of 28. Now let's look at that, inches or whatever. Let's look at those answers and see if they pass the ballpark test. Is the biggest side of the triangle opposite the biggest angle? Is the smallest side of the triangle opposite the smallest angle? There's the smallest side, 10, and it's opposite the smallest angle, 28. So that's what the ballpark test tests. Make sure your longest side, which is C, is opposite your biggest angle, and that your smallest side is opposite your smallest angle. If that isn't true, then you've made a math error somewhere. And I guess the third test would be the middle side is opposite to the middle angle. If all three of those are not true, then there's something, you've made a mistake, either in entering it in your calculator or whatever. So that's the best ballpark test to use on these problems. Okay, now these are relatively easy. Let's go ahead and do another easy one, and then we'll start talking about the only case that's hard, which is the ambiguous case of the law of sines. Have you had that? It's called the ambiguous case of the law of sines. And what it means is that sometimes those three pieces of information they give you do not produce a unique triangle. They produce two possible triangles. Okay? But I'm not going to get into that unless you have a problem that requires it. And we'll spot it if you have it. We'll just go ahead and let's continue on with what you've got. I don't want to go beyond the degree of difficulty that you need to know. That can be confusing, and there's no need to confuse if they're not teaching you that yet. They probably aren't. Is this a full trig class, or is this just trig that's part of Algebra 2? Okay, then they probably are not going to have to deal with that ambiguous case yet then. Okay, what else do you have? That's a good one. Do you have one where there's only one angle and two sides? Because when you have two angles and one side, you can always instantly figure out the third angle. without using much math at all. Okay? So the ones that are a little more difficult is one where they give you only one angle and two different sides. Okay, what's that one? Must be a right triangle, because that's the only way that's possible. Yeah. This is actually easier, and you're not going to need to use the law of sines on this. Go ahead and give me what they... Where is A? Is A the right angle? B is at the top, C is there. C is what? 27? Okay. Okay. Now, again, because this is a right triangle, you can use trig functions. You don't have to use the law of sines. You don't, you actually do have an angle and its opposite side, but that's not the way you solve right triangles. The law of sines is used for non-right triangles, not right triangles. So what relates 12 and little a? Which trig function of this angle? It's the only angle we know at the moment. What trig function for that angle relates 12 and a? Yep. So cosine of 27, we're always taking trig functions of angles, equals what? Cosine is what? SOHCAHTOA. You need to memorize that and not forget it. That's the basis of trig. If you don't remember this, you can't go forward. Okay? So what's cosine? Based on SOHCAHTOA. There you go. Adjacent over hypotenuse. Okay? Which makes A, if I do this algebraically, 12 divided by cosine of 27. So what is that number? $13.47? Okay. That makes some sense because this thing is 53 degrees. No, 63 degrees. So 12 would be opposite 63, and 13.47 would be opposite 90. So that makes sense. And then this side over here is going to be smaller than 12. It would have to be the smallest side. Do they want you to solve for that side, or do they want you to just solve for the hypotenuse? Okay. Yeah. SOHCAHTOA, figure out a way to remember that. Herons, okay. Actually, this has two names. There's Heron's formula, and it's also called Hero's formula. And both are correct. A lot of these math names of formulas actually have nothing to do with the person. Pythagorean theorem was not discovered by Pythagoras. Raleigh's theorem in calculus had nothing to do with Raleigh. In fact, Raleigh was a major mathematician who went to his grave believing calculus was not correct, that it was an incorrect math, and yet they named a calculus theorem after him. Okay, so we're going to use that formula for what kind of triangle? What are the three side lengths? Okay, and according to Heron's formula, what's the area equal to? You don't have it in front of you? I don't either. Huh? Okay, let me look it up. Because I don't have it memorized either. In fact, I'm going to have to look it up. Back. Heron, 559. And they got Heron and then in parentheses, hero. So it's the same person. Well, I'm doing it. Alright, this is the one. It's the square root of s times s minus a times s minus b. Not really that hard to memorize. I don't know why I have problems with it. Where s is the semi-perimeter. Okay? So what's the perimeter? Nice of them to give you such big numbers here. Just to make it harder, right? So use your calculator. What do you get? Now take half of that. What do you get? That's the semi-perimeter. So the area, notice it wouldn't be easy to calculate the area of a triangle. It's not a right triangle. You don't know anything about the height, or you know the base, but you can't figure out the height. So this is actually a pretty valuable formula for calculating the area of a triangle. Here's what it's going to be. I'm going to let you do the math. That's s minus a. That's s minus b. And times s minus c. Okay? So basically becomes 729 times that difference, times that difference, times that difference, and then the square root of all of that. Like I said, nice of them to give you such short numbers, huh? But that's what it is. Okay? And then you can, that's a calculator. Yeah, I'm not doing it on the calculator, so I'm not going to know whether you got anything that makes sense or not. What did you get, though? 62,598. Did you take the square root of that? And is that after you took the square root? Okay. So let's see if that makes sense. If I draw a triangle similar to the one they're talking about, and I give it a base of 680, and I give it a short side of 312, and I give it a long side of 466, then that height is going to be approximately 200, we'll say. All I'm trying to do is ballpark it. So I know the area is 1/2 the base times the height. So 1/2 680 times an approximated height of 200. That's 100 times 680. So that's 68,000. Perfect. 62,000. Definitely in the ballpark. And that was just eyeballing what that height would be. Just taking a guess. I know it's got to be less than 300. You know, it's a shorter line than that one. Okay. What else you got? That's actually a pretty easy one as long as you remember Heron's formula. In other words, the rest of it is trivial. Okay, what else? Okay. The elevation of a plane. Airplane. Okay. Mm-hmm. Four. Okay. Okay. So is my triangle that I've drawn accurate? Here's the plane right here. In other words, the height of 32,000 makes that side of the triangle 32,000, right? Because we know the height of the airport is 0. Right? It's on the ground. Okay, there's the 4-degree angle of depression. And they want to know X and they want to know Y, correct? Okay. The horizontal distance is going to be X, but the plane is actually going to travel on this path. In other words, they're going to slowly lose altitude and land at the airport. So it's worth knowing both X and Y. Okay, how can I figure out X? Think trig. You need a trig function that relates the angle 4 degrees to X and 32,000. No. You relate? No. Sine and cosine use the hypotenuse. Right now we're just talking about X. We'll get to the hypotenuse next. But the horizontal distance is X. So, okay. So what's the equation? Always start your equation off with the trig function, then the angle, which is, and what is that equal to? Knowing SOHCAHTOA, TOA is over TOA, opposite over adjacent. There's only one variable in that thing. So X is equal to 32,000 divided by tan of 4 degrees. What do you get? Okay, that actually kind of makes some sense because 32,000 is opposite the really short angle, the shortest angle in this picture. So x is going to be opposite. This angle down here is actually 86 degrees, right? In other words, these two angles are always complementary. So that's very definitely a possible answer. It's not out of the ballpark at all. Now let's figure out y. What trig function are you going to use to solve for y at this point? You got all kinds of them you could use. Okay? Give me whichever one you want. You could actually use most anything because we've got two angles, we've got all sides, so go ahead. Sine of what? We always take trig functions of angles, not of sides. And again, y is going to be 32,000 divided by the sine of 4. What's that? Should be a slightly bigger number than what you got. Yeah. So they actually have to travel a little bit further to land. But that beats going this way, where they go this way and then drop straight down and crash. Okay. What else? Okay. Well, that's fine with me. We can, no, I'll let you call that the way you see it. So that's fine. Okay, Brandon, you're welcome, and I will talk to you next time. You too. Bye-bye.